In this example, it wants us to write a linear model for the average meat prices. Now remember, we were looking at two models. The average price for a pound of fish, we saw that there was a curve to it, so that's not best represented by a linear model. And then we had our average price for the cost of a pound of meat, and we decided that that was well represented by a linear model, by a line. Now the types of linear models we have are our slope-intercept form, our point-slope form, and our standard form. So this example wants us to write a linear model. Remember, when we write a linear model, we need to find the slope and the y-intercept, or use a slope and a point in point-slope form. Let's look at our graph here. You can pick any 2 points you want as long as they lie on your line. They don't need to be these blue dots. They can be any dots in between. But before we get there, we need to, just for the ease of the problem, we need to make a little correction here. Let's call this year 0. Let's call this year 1. I'm sorry, I shouldn't say year 1. Year 1, year 2, year 3, and year 4. Okay. Actually, I want to apologize. I want to make another fixture here. We're going to call year 1991 year 0, and this is going to be the years after 1991. Okay, so our x value here, x-axis, is going to represent the years after 1991. And the reason I want to do that is we don't want to be dealing with these type of years when we're working in our equation. Okay, so if this is 1991, we're going to call this year 0. 1993 would be 2 years later. 1995 would be 4 years later. 97 would be 6 years later, and 99 would be 8 years later. Okay, it's always helpful to just assign this because these numbers are easier to deal with. Okay, so 1991 we'll call year 0, and then we'll talk about the years after 1991. So again, pick 2 points on the line. They can be any 2 points as long as they lie on your line. So if I look at my line here, I'm going to use this point right here, which is the point 0, and again I call it 0 for 1991, and 2.5. And I think I will use maybe this point here. Again, you could use any of these. You could use something that falls in the middle if you wanted. Okay, doesn't matter. I'm going to use the point 8 because 1991 was 8 years after 91, and that is at 3.5. I guess we're talking about dollars here, so I should do that. So now we're going to use these 2 points to write an equation. Remember, we need to find our slope, and we can do that with the difference in our y's over the difference in our x's. So I can go 350 minus 250 over 8 minus 0. When we do that, that ends up being 1 over 8. Now you can totally leave it as 1 over 8, but a lot of times with real life problems, we end up changing the slope to a decimal. I know I've told you always leave slope as a fraction, but with real life data, it's easier to change it to a decimal because remember, with the best fitting line, people's equations or models can be a little bit different. They're going to be close, but they can be a little different. So I'm going to divide this out and just use 0.125. Okay, again, if you left it as 1 over 8, that's fine. Now what we could do is we could use slope-intercept form, plug in our slope and a point, and figure out what b is. Or now we have our tool of point-slope form. Y minus y1 is equal to the slope times the quantity x minus x1. So let's plug in what we know. We know our slope is 0.125 or 1/8, and then we can just pick a point. I usually pick the one with a 0 in it, so I'm going to go x minus 0. And over here I'm going to go y minus 250. I use this point right here, but you could use either. Now we could leave it like that, but really let's solve for y, and I'll talk about y in a second. Okay, so we're going to leave it as y minus 2.5. Here we have to use our distributive property. But when we go 0.125 times 0, we just get minus 0. So we really don't even need that. Okay? And now I'm going to add 2.5 to each side. We end up with y equals 0.125 times x plus 2.5. The reason I wanted to put the model in this form is because now if I want to put in a year after 1991 for X, I can quickly find out what I expect the price to be. If we would have left it in this form right here, I would have had to do a little bit more work. I would have had to put the number in for X, I would have had to multiply it by 0.125, and then I would have to add the 2.5 to each side. Okay, so if we do that originally, then I can say what will the price be after 10 years, what will the price be after 50 years, and we can quickly figure it out. So it's always helpful to eventually write your linear model in slope-intercept form because we're able to make predictions better. Use point-slope form, and then you can turn it into slope-intercept form. This model here, this linear model, represents this line that we drew, our best fitting line.